Hello, so we are going to solve night dealer problem of LeetCode 1935. So question is like the chase knight has a unique movement. It may move 2 square vertical and 1 square horizontal or 2 square horizontal and 1 square vertical. Both 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 forming the shape of L. That's mean if you are at 1 minute. If you are at currently this position, so either you can move two square vertical and then left, right, or 2 square vertical then left, or 2 square downward then right, and 2 square downward then left, or 2 square left then upward or downward, or 2 square left in downward or upward. So basically for each position you are having 8 options to move, but we are having some constraint like that. If that resulting option is out of bound, that means if resulting option is out of the square, then you can't move that one. So suppose if you are at this position, so you can't move in this direction, you can only move in left, up and left, right and down and left, or left in down or left in up. So you can perform only few operation on which we are moving inside the chessboard. You can't move outside the chessboard. That's the typical movement that we can perform. So in this question, it is like you are having a 4 3 cross 4 matrix, and you can perform moving from any one direct in any one position of this, but you can't start from this star or hash, or you in any step you can't move to that star and hash, and so on. With by avoiding star and hash, you have to result how, if you will give you can perform n number of moves. So what are the unique n number of moves you can perform inside this keyboards on without using hash and stars? So that's the question. So you have to chess knight and phone pad as so below. The knight can move only stand on the numerical value, that is in blue color. You can't move on hash numbers. So you are allowed to place the knight on any number cell initially, and then you should perform n minus 1 jump to dial a number of the length n. That means you can start from any position 1 2 3 4 5 6 7 8 9 and 0, and after that in first step you can jump on any position, and after n minus 1 step, remaining n minus 1 step, you can move in any valid direction. So the thing is you have to return how many number of possible move you can perform. In other words, how many possible number you can dial by using valid moves. Actually the total number of move can exceed int limit, so there is having some constraint answer modulo. That means whenever you notice your answer exceeding this limit, you can modulo. So what will the first approach that we will follow? The first approach is, so this is the sample board that we are having, and we have to follow some steps. So for any position we are representing in form of I and j. So I will represent the row number and j will represent the column number. So suppose if you are having position 1 1 1 and 3, that's mean we are having uh, 1 here, 1, that means first row, and 3, sorry, we can't make 3 here. Suppose we are having 1 and 1. So 1 will represent first row, and this one will represent first column. That's mean we are currently our pointer is here. So we can perform few operations. Either we can go two point upper direction and then left. So if you will go 2 point upper direction, then you are going out of bound, so we can't perform this operation. Another thing is we can go two pointer two pointer Another possible move is 2 point down direction then left. It is also invalid, so we can't perform this also. Another possible operation is 2 point down then right. It's also invalid, so we can't perform any operation from this one. Or same one, we can't we can notice that thing, we can't perform any operation from 5. But if you are at 8 position, so we can perform 2 point upward direction then left, or 2 point upward direction and then right. And so we can perform only few operations from it also. So first thing is we can perform for what will the next position, we can check few things. We can we can move 2 point upward direction. That's mean if you will go 2 point upward direction, then it will be I minus 2. And in J we can, after I minus 2, we can perform either go in left direction or either we go right direction. So if you are going in left direction, then it will be J minus 1. If you are going in right direction, then it will happen I minus 2 and then J plus 1. On the same way, if you are going down direction, then it will be I plus 2 and J minus 1, or I plus 2 and J plus 1. And if you are going in left direction, then I will be changing by 1 and J will change by 2. So the thing will be I minus 1 and J minus 2. That means if you are here, if you are, suppose you are at the 6th position, so we can go 2 point in left and then 1 point in downward, or 2 point left and 1 point in upward. So if you are moving in left right, then J will change by 2 and I will change by 1. And if you are moving up and down, then I will change by 2 and J will change by 1. So for the each position, we have to check 8 possible combination. Either J will change by 2 and I will change by 1, or I will change by 2 and J by change by 1. And for each change in I, either it could be plus or either it could be minus. And for J also, either it could be plus and either it could be minus. So there will be the 8 possible combination that we can perform for next operation from any position. So the next possible combination will be the, either will change increment I by 2 and J by 1, either we can increment I by 2 and J by minus 1, or minus 2 1, or minus 2 minus 1, or minus 1 2 and minus 1 minus 1, so on. We can perform 8 possible combination. So we, for each position, on each position we will try all 8 possible combination. And for each possible combination, we will check is it is valid or not. If it is valid, then we will jump to the that point, and then after moving to that point, again we will recursively try the all possible combination. But whenever we are moving to one point to another point, our next step will increase by 1. That's mean the possible move that we can perform, it will decrease by 1. So, and for each position we will calculate what will the possible combination if we are moving if we be moving in all possible directions. So first we are, if we are having at position I and J, and the possible move we can perform is N, then this ij will change by 8 option. We are having to change I and j by 8 option, and after changing 8 option we will decrement n by 1. and whenever we are getting it is last move, that means if n is equal to 1, if uh, if if n is equal to 1, that means we can't move any further, so then we will return 1. We are having no choice to move, we will return from that point. So for each position we will try all the possible combination, and for each possible combination we will count how many the possible combination after that one, and then we'll sum all possible combination. So the recursive code will be, so we will solve this by recursion. So the recursive function will be, if first we will check the next move, that the move you are trying it is valid or not. That means if I is less than 0 or I is less than 4 or j is less than 0 or j is greater than 3 or I and j is I and j is -1. -1 because in a table I have created table of all these numbers. In table for star and hash both are the invalid position, so for that I have put it -1. So we will check it, if it is invalid position then we will return 0, that means it is invalid move. And if n is equal to 1, that means if our next move count is remaining move is 1, that means we can't move further, it's last one, then we'll return 1. Otherwise we will try all the possible combination, 8 possible combinations. That means we will try for each move in a row and each change in column, and then we'll decrement n by -1. That means the number of move that we can perform will decrement by 1, because each at each step we are utilizing one step. That means we can dial only n point of number. So whenever you are moving to the one point, you are dialing one number, so remaining number that we can choose will decrease by -1. So for change in I and j we are performing this type of pair. That means we can change, we can increment I by 2 and j by 1, or we can increment I by 2 and j by -1, or we can increment I by -2 and j by 1, and so on. We will try all the possible way that we can perform, and for each way what is the result we are getting, we will sum in some variable, and after performing all the possible operation, whatever the result you are getting, we will return that one. And if we are if this number is exceeding the limit, then we will apply modulo operation. So this is the recursive for the code for the same. Let's run it. So if you are applying recursive code, then it is running. But if we are changing that number, test case, if you are changing this number by, suppose we are putting 1000, and then after running, it's giving TLE. That's mean for each position we are trying 4 option. So if for each position we are trying 4 option, so first on first position we are having 4 option, and second position also we are having 4 option, and third position also we are having 4 option. So total number of option we are trying will be the 4 to the power n. And definitely if you will try all these option, then it will be the 4 to the power n. It's NP hard problem, so it will not execute within the time limit. So we can try few things. In all the possible combination, there are many combinations that we are repeating. Suppose we are reducing I by 2 here and j by -1. If in other option, if we decrease I by -1 and j by -2, and then again I by -1 and j by -1, then we will reach to the same point. That's mean there will be many positions that will be that we will recompute. So to avoid recomputation, we are maintaining one table. We can try other method. That's a DP approach. So there are few options. I can vary from 1 to 4 only. So there are only few positions for I. Either it should be 0, 1, 2, 3, 4. And for J we can move only 3 options 0, 1, 2, 3. So we can perform only I in 2 position. I we can vary I from 0 to 3, J from 0 to 2, and for N we are having limit of N is equal to for the limit of N is equal to 5000. That's mean we can't move more than the 5000 N. So the N vary from 0 to 1 5000, I vary from 0 to 1, and J vary from 0 to 3. So we have to compute only few combination. So whenever we are getting before computing anything, we will try in our table if it is already calculated. That means if their value is not equal to -1, initially before computing anything we will assign all the value of that table with -1. So whenever we will going to compute any new table, we will try if it is already calculated. That means their value will not equal to -1, then we will simply return already calculated value. And if it is not the case, then we will compute that value, and after computing we will store the new value in table, and after computing we will store the new value in table, and then we will return the value. So this will be the DP approach. So in DP approach we will store all the value in table, and after computing we will return the already computed value if we are going to recalculate the same value. So I hope now it will run for that case also. Yeah, it's running. Let's submit it. Yeah. So what will the time complexity of this one? So the time complexity is we are calculating, we can't calculate more than this value. That's mean we are calculating only for I is equal to 0 to 3, j is equal to 0 to 0 to 2, and n is equal to 0 to 500. So total number of function call is will be 4 into 3 into 500. That is the maximum one. So it is order of 500. That means it will depend on the order of n. It will be approximately order of n, where n is here n is maximum value 5000. So the time complexity will order of n, and space complexity will be also n, because we are using a table of 500 into 3 into 4. So I'll put the code link in description. You can check it out. Thank you.